Welcome to Team Otter Penguin's DinoStocks DevOps deployment presentation. Team members consist of myself, Chad Thompson-Smith, a U.S. Navy veteran and dual Code Platoon graduate, and the other half of Team Otter Penguin is Matt James, a U.S. Army veteran and cloud engineer. Our project overview shows that we use GitHub for collaborative version control, GitHub Actions for CI/CD, Docker for containerization and image creation. The application was deployed on Amazon's Elastic Kubernetes service. On that EKS cluster, we have a backend pod that's a Django application serving as a RESTful API, a front-end pod that's a React application served by Nginx. Nginx has a dual role as a static content server and a reverse proxy for the Django RESTful API. And finally, we have a Postgres database that's interfacing the Django RESTful API. As a two-person team with numerous project objectives to accomplish, we decided to use agile sprints to manage the workload, with Chad focused on configuration and Matt focused on provisioning. Now Matt is going to review the cloud architecture diagram and infrastructure as code.
This represents an overview of the infrastructure supporting the DinoStocks application deployment. It can be read top to bottom and left to right. At the top, the developer or provisioner uses Docker build and push to send images to the Docker Hub repository. They also use kubectl to interact with the Amazon EKS control plane, and through the control plane, the pods and services. Along the center line, you see the user experience. A user, outside of AWS, reaches out and touches the DNS routing for the load balancer service, which relays traffic to 5173 that interacts with the front end, which then relays through the cluster IP routing to port 8000 on the back end, and finally touches the Postgres server on port 5432 using the final cluster IP relay service. The infrastructure supporting the EKS cluster is built in Terraform, using a number of .tf files. In the case of this project, it is broken down as follows: providers, main, IAM, route 53, variables, and a tfvars file. The providers file designates source, versioning, and the US East 1 region, in this case, linked to a variable. The main file shows the EKS cluster resource, the working node resource, and the security group. The IAM file designates the required structures and policies identity and access management needs, namely roles and the policies attached to them. You can see in the file the resource declaration for the EKS cluster role and the attachment of the relevant existing policies to that role. Likewise, you can see a role for the worker nodes and the attachment of a relevant existing policy for that role as well. Additionally, a custom policy is created for the monitoring dashboard that will be covered later in this presentation. Route 53 shows the framework necessary to create a DNS record that can attach an existing hosted zone to the build. And the variables file allows for the centralization of values for efficient changes to the deployment. And finally, the tfvars serves as a discrete space to declare sensitive variables.
This Docker file orchestrates a multi-stage build process tailored for our Django backend image. Initially, it builds a Python environment, compiles dependencies, and prepares our application's machine code. In the next phase, it switches to an Alpine-based image, establishing a minimal footprint while transferring only essential elements for runtime. The final image, equipped with Gunicorn, is ready for deployment, mirroring the fidelity of our application across all stages of our CI/CD pipeline. This Docker file represents a holistic approach to application containerization, emphasizing efficiency, security, and adaptability across development, testing, and production environments, facilitating seamless transitions from development to deployment in a scalable and manageable manner. This Docker file crafts our React frontend image. It begins with the latest Node.js environment, setting a solid base for assembling our app's dependencies and build. Upon initializing, the Docker file installs all necessary npm packages, followed by the transpilation and bundling of our React application into optimized static files. The build stage culminates in a collection of output files ready for serving. Transitioning to the production stage, we adopt an Nginx Alpine image, known for its lightweight nature, to serve our front end efficiently. Nginx is configured as the robust web server, forwarding client requests and serving the compiled static files, thus bringing our user interface to life. Our Docker file embodies a streamlined front-end deployment approach. It aligns with our backend practices, ensuring secure and scalable delivery of our web application. The Docker Compose was the linchpin in the local development workflow, enabling the multi-container setup necessary for the Django React PostgreSQL application. This file defines three services: DB, backend, and frontend, each tailored to streamline the development and testing phases. The database utilizes the latest PostgreSQL image, setting up a dedicated container named my-dinostocksdb. It's configured with environment variables for database name, user, and password, mimicking a production environment for backend connection testing. Backend builds from a Docker file within our backend directory, creating a container named Dino App Backend. It's designed to apply database migrations and launch the Django development server, all while dynamically linking to our database service for seamless data interaction. Frontend constructs from a Docker file located in our frontend project folder, leading to the creation of Dino App Frontend. This service ensures our React application is accessible on the specified port, fostering an efficient front-end development experience. This Docker Compose setup leverages containerization to ensure consistency between development environments and eliminates the "it works on my machine" issues. It provides a solid foundation for developing, testing, and debugging our application in a manner that's both scalable and easy to recreate. Our deployment to the EKS cluster used several K8 files, as you can see here. I'm just going to focus on a couple for the demonstration. Our backend deployment file, which you see here, is what deploys our backend Django pod on the cluster. And to get that working fully, we need to actually run a couple temporary init containers that will spin up and then spin down. They use the same exact image that the backend is using, but they just serve one function. And this one here just spins up and it will migrate our PostgreSQL database back into the database. And then you have another init container down here that will load data from a local JSON file in the backend pod to the database. So this is essentially a seed script. So these two init containers work to get our backend pod configured and ready to go. The other K8 file that I'm going to focus on is my Nginx config map for my front end. So one of the challenges that I ran into when I was getting the application code base transitioned from a local dev environment to production ready was the front end requests were all pointed at localhost. This will not work in a production setting, so what I did was I used the Nginx config map to minimize front-end code cleaning and modification, and configured the Nginx pod to the specifications of the React application. So this configuration here takes all the calls from the front end and then uses the Nginx as a proxy. And you can see that that config map is just mounted on a volume that's mounted on the pod. This allows my front-end code to not be changed and still communicate with my backend even though they're on separate pods and no longer on localhost. This GitHub Actions workflow is the backbone of our CI/CD pipeline. designed to automate the build and deployment of our Django React application on AWS EKS. It triggers on every push to the main branch, ensuring our application is continuously integrated and delivered with the latest changes. The workflow breaks down like this. Environment variables are set for Docker credentials and AWS credentials. In the build portion of the workflow, the Docker credentials are used to build and push fresh images to Docker Hub. In the deploy portion of the workflow, the AWS credentials are used to push those fresh images to the EKS cluster. This pipeline automates the tedious task of building Docker images and deploying them to Kubernetes, reducing manual errors and speeding up the delivery process. By using GitHub secrets for sensitive data, we ensure our pipeline is secure and our credentials are not exposed. With every commit, our application is automatically updated on AWS EKS, supporting a scalable and resilient infrastructure. The CI/CD pipeline is an integral part of our DevOps strategy, ensuring our application is always up to date, secure, and efficiently deployed. Okay, I'm just going to do a quick demonstration of the CI/CD pipeline. I've got a commit here ready to send, push on up to the repository, so I'm going to go ahead and do that. So that will push on up to my repo here. And we will see here my last successful build was an hour ago, and now we are starting the build here. I am going to pause, but I want to quickly just show this as a build and then a deploy. And I'm going to pause and then we'll catch back up here in a second. Just a quick look here at the build process. It's just building the images and then pushing them on up to Docker Hub. It's actually doing that right now. All right, now the build portion is complete. And as you can see now, we are deploying to the Kubernetes cluster right here on AWS. It's deploying the database right now, then it waits 15 seconds to give the database time to spin up, and then it will apply the rest of the K8 files and get the cluster up and running. And you can see here that we have a success with our build and deploy. It took about 3 minutes and 20 seconds to run this job. And if we go over here to my Docker Hub, you can see a couple hours ago, I pushed images. That was my last time I ran this workflow. But if we go ahead and refresh here, you're going to see how it was a 1 minute and 2 minutes ago. So we've got fresh images pushed up by our CI/CD pipeline with GitHub Actions.
You can see in this .tf file the node monitoring dashboard creation. The resources created here, and a long string of metrics is created within that dashboard. You can see the type is metric, the positioning, the sizing, and the properties, how long, label, and so forth. As you can see on the right here, there is a long list of metric widgets that are compiled together to give a good picture of what is going on in the node. The deployment of that code in the .tf file creates these metrics and charts. With this monitoring, it permits us to have real-time access to what is going on from a performance and stability perspective.
And now for a quick demonstration of the DinoStocks application. We're here on the landing page, and as you can see, I've already logged in. We're going to go to the overview here, and you can see I've already purchased some stocks, but we are going to purchase some more stocks. We'll go ahead and purchase some more Triceratops. We'll buy 10 more shares, and we'll go to our overview. And now we have 20 shares here. This is crediting to the backend PostgreSQL database. The Nginx is proxying the backend, and the backend is then hitting the database. And as you can see here, we've shown that we can retrieve and update here. We'll go ahead and sell all of our shares. We'll just sell 20. And as you can see, that deleted that from our database there. So we have full CRUD functionality from the front end using Nginx, hitting the back end, and then hitting the database. We'll hit the About page here real quick. And here, just remember, don't put all your eggs in one dinosaur nest. And that concludes our DinoStocks demo and presentation.